I've taught this class for a long time, and I think the spaghetti diagram, because it's so simple and a lot of people are familiar with it, discount it as an important tool. I think it's probably one of the most important tools that you can use almost any time when you're analyzing a problem, analyzing a workflow, and it isn't quite as simple as what people make it out. I'm going to bring up the PowerPoint here. I'm going to assume that people at least know what a spaghetti diagram is. Most people do. As I said, one of my favorite tools. This is easily accessible. People understand it. There are several Lean Six Sigma tools. I counted at one point better than 2,000 of them. A lot of them are statistical tools. They are not commonly used, but this is commonly used, commonly understood, but it is not given the credit it should because it's highly versatile and it reveals a tremendous amount of information very quickly. So why don't we get to it? We'll explain, first of all, what it is and what kind of problems it can find. These are some pictures I've just pulled off of everywhere. Sometimes students send me some. The top left here is a high school in Texas. Somebody over the summer decided to redirect traffic flow. Unfortunately, they forgot that you needed an up stairway too. Obviously, that didn't work out very well on opening day. Problem with the bench there, easily prevented. Stairways, these type of problems. That's the whole point. A lot of these problems are easily prevented, but they're not foreseen. People don't actually use some sort of tool, and there are lots of them to prevent this sort of problem. These will occur. So it's not just traffic flow with people. That's an important one, but it's also information flow and just about flow of almost anything. Obviously, there's one with water. There's no reason that wouldn't work if you wanted to plot that for some reason, an irrigation system or whatnot. There are some other pictures people have sent me. These are all highly preventable problems, but the point is they weren't prevented. They occur all the time. And you look at them and you think, how could people be so stupid? Well, they aren't stupid. They simply didn't analyze the problem before they had a problem. So here's some others. They're not hard to find. There's some pretty amusing ones out there on the internet people post. Again, all easily preventable. This is a formal spaghetti diagram, probably done by a black belt or a green belt at a factory floor. It shows the traffic patterns between these different workstations, and this is a pretty good workflow. There's really no big problems here. There's a problem that is unrelated to a spaghetti diagram. If I see, you can see the blue boxes on here. If I see quality checks sprinkled willy-nilly everywhere in a workflow, that indicates a gigantic problem that has nothing to do with quality checks. Quality checks might be a Band-Aid, but we've got other problems. But this is a pretty good workflow. Certainly it leaves a lot of empty space. There are certainly instances like that, but as far as workflow goes, this is a classic spaghetti diagram. This is analyzed over, we don't know what period of time, but it indicates where most people are walking through the course of the day. A typical food service, like if you're going to go into a place and order a sandwich or whatnot, and you walk up to a desk, unfortunately, many times when people are laying out workplaces, the first time they lay it out, there's some semblance of order and logic to them. As they get new equipment, the new equipment in an office or a factory, or in this case, food service, goes where there's an electrical outlet or there's some sort of an easy install. And that often is not the best place for that piece of equipment, but it's quick and easy, and the guys delivering it, of course, don't want to take any more time than they have to. So it gets stuck wherever it's supposed to be, and it doesn't work out. So it causes problems, especially you got food service by its nature, time sensitive. And if you got people bumping into each other all day long, it just causes not only slow production line, but it also causes a lot of frustration in the workers. Easily avoided. You can see it was analyzed in the second one. They actually came up with an order so that people are passing this sandwich or whatever they're working on, rather than everybody bumping into each other, trying to, they got a real assembly line rather than just everybody making sandwiches. Now, healthcare is one of the real hot topics for Lean Six Sigma right now. We have some hospitals here in the Northwest that are world leaders in efficiency, and they provide a much better quality outcome to their patients because of that. Lean Six Sigma is not about cutting work or reducing the important work. It is all about eliminating work that doesn't have to be done. You've heard, no doubt, people say, let's do more with less. That is absolutely counterintuitive to everything we're talking about. We do less with less. We're trying to do less work. We eliminate work that doesn't need to happen. Now, on this spaghetti diagram, you can see the blue and the red. They indicate, repeated lines indicate how many times this area was walked. And you can indicate, I mean, there are many ways of doing this. Now there's ways to automate this so you're not doing it manually. But you know, if you don't have that equipment, there's no reason you can't do a spaghetti diagram with a tape measure and some graph paper, and then maybe put it on a whiteboard. That's perfectly good. It works every single time. It doesn't require anything special, and that was the way it was always done. Now there are much more sophisticated ways of doing it, but nonetheless, it amounts to the same information. So this is a very good analysis of a workstation, obviously overloaded, but it indicates where people are concentrating most of their time. Now we're going to get into what people normally don't associate with a spaghetti diagram, but nonetheless it is. This is disease vectoring, and we've, of course, the last few months we've been hearing a lot about this. How are diseases spread? This one is from a hospital in the Midwest, and they had an outbreak of an infection. It was very difficult to treat, and they wanted to know, where in the heck did it come from? How is it spreading? And it was a good hospital. They did everything they were supposed to do, and they did the analysis, and they found out how this infection was spreading between patients. And as you can see, they have all the normal people who work in a hospital, including the patients who are, of course, just there short term. Who is spreading this? Well, there's only one group of people who goes absolutely everywhere, and those are the nurses. So you normally look there first. In this case, yes, the nurses were inadvertently spreading this infection, but the initial infection came from a doctor whose hobby was raising roses, and he got an infected finger, which he treated right away. Had no reason to think there was a problem, and it into a sterile environment that caused enormous problems for months. But if you don't do the analysis, how do you know this stuff? How do you know it? Again, other tools besides just this one were necessary, but this is a pretty critical one. Now, while we're talking about healthcare, again, you know, one of the first things nursing staff have to learn are blood type compatibility. And this is a lot of memorization, or you can just post this graph up on the wall and nobody makes a mistake. It's very simple. This is another form of a spaghetti diagram. Very simple, but the amount of information on it is pretty formidable. Mostly, you know, if there's any confusion, if you're rushed, you're kind of getting brain fog at the end of the shift, you could look at this in a heartbeat and never make a mistake. They're very, very handy for references and teaching tools. So don't ever discount being able to do, like training new staff. When you hire new people, huge amount of information has to be imparted, and you're relying on people's memories. And when people get overloaded, that memory suffers. So these sorts of very straight ahead graphical displays of information go a long way to make sure that people are broken in properly, they understand the importance of things, and they don't make mistakes. Don't just hire people and throw them into the deep end of the pool and hope for the best. We can do a lot better than that. And this is a mutation map, and it displays how genetically this virus mutated and what effect it had on other genes within that chromosome. So again, this is something that, unless you're in healthcare, you're never going to do, but it displays the versatility of a spaghetti diagram. Now, you can certainly write a report and with standard text explain all this. This would take pages and pages and pages, or you can have a visual display. The human brain responds very favorably to visual displays, and people look at them, say, okay, I get it. Very quickly, very succinctly, and it's an easy reference from that point on if you need it. Again, some of these things I'm going to show you, are not classic spaghetti diagrams, but frankly, I'm not a purist. I don't care. It works. It works very successfully, and people can grasp it, and that's what I'm after. Lean Six Sigma is hyper practical. If it isn't usable, we just throw it out. And so as far as purity goes, some sort of philosophical purity or whatnot, forget it. Typically, we're not very concerned about that. How are various disorders, cardiovascular, digestive, how are they interacting? We could write several textbooks on this, couldn't we? This is a graphical display of the same information. Now think about all the different steps, perhaps in a work plan that you have at work, and how they're interconnected. What affects each step? What step affects other steps? Very complex things, or it can be relatively simple if you throw it up on this type of a display. This one I like a lot. I just found this last couple of days. This is a spaghetti diagram of how whales and dolphins migrate around the oceans. Again, we could use standard text and write a description of this. I doubt if people remember very much of it, but if you have a graphical display like this, which this is a spaghetti diagram, then it's very easily grasped and very easily used as a reference. Now, if we wanted to make this more information added to this, which many spaghetti diagrams have, then you could throw in what time of year they're in what locations typically. There's many different types of whales. Where are they typically at what time of year? Or you could even throw in, where are they calving? Where are they eating? What do they eat? You could throw in their numbers. If there's an attrition point somewhere where some of the whales and dolphins die off, you could indicate that. So there's no reason these things really have to be simple. You could throw in all the information you could think of in a display like this, and it would be on one page. It'd be simple, and people would have it. There's no reason to make things more complicated than they need to be. When I talk about casinos, there's a reason. For our purposes, this is a very interesting topic because the casino industry is got the leading edge on a lot of different technologies, and they are not the least bit concerned about whether they should use them or not. While the police departments, governments are wondering if they should use facial recognition at airports or, bank lobbies or whatever, the casinos are not. They use all of this stuff. So if we want to find out how it works and what it works best for, we can. There's a perfect market out there that we can look at. I have worked with most of the local casinos, and I I've got a pretty good grasp on what technologies they use and why they use them and what they're used for, and the problems they're faced with every day. Um, if anybody thinks running a casino is just installing a bunch of machines and raking in the money, it's a complicated and highly competitive business. Basically, every casino sells the same thing, so they have to provide the best service to their people. So this is the bottom left here. This is what a casino floor looks like to their computer. And they have a graphical display. There's not typically somebody sitting there watching it all the time because they don't need to. But when you get the players cards and you charge it up with some money and maybe play some of the machines or whatever, obviously there's a chip in there. No, everybody kind of understands that. That's how you can charge up some money in it. But it also tracks where you're going and what you're spending your money on. If you buy lunch or buy drinks or whatever you do, it tracks all that. Or if you go to the gift store and use that card to buy something in the gift store, they're happy to take your money for anything. These places are extremely carefully designed, and there's very few mistakes going on in a casino. So those chips track what you do. I don't gamble. I've been in a lot of casinos, and I'm pretty much a disappointment because I never get an invitation to come back because I don't gamble. But the people who do, they know exactly what games you play. They know how to advertise to you, and they know what kind of a customer you are. They know how much money you're spending. All those things are tracked. So when we're talking about chips, this is a very important topic. And what do chips have to do with the spaghetti diagram? Well, I mentioned earlier that the spaghetti diagrams now can be automated, and they are automated with tracking chips. The chips are in a lot of the products we buy. So they can track where those are. Now, Walmart started this. Every pallet of any kind of merchandise that comes into a warehouse for a Walmart has got a chip on it, so they know where it is at any given time. So they can track. It's pretty efficient. They can get things to the market when they're needed. They don't have warehouses at the stores. Things are delivered as they're needed, so they have to be tracked very tightly. So these chips you're seeing, it's a pretty good representation of the current size of them. What do those things cost? Is this really, really expensive? If we're going to track our merchandise, well, those chips right now are about 6 cents each, and you can get freebie readers. So just the software, I should say, is freebie. You can get very sophisticated software if you want, but those chips can track where you are and where our merchandise is and what it's doing, if it's sitting or where it is at any given time. And that's about 6 cents. And people are using these in just about every kind of industry and for very practical means. Now, this is a spaghetti diagram. It tracks the movement of, in this case, merchandise, but it can be people too. There's no reason you couldn't track people if that became important. Where are they at any given time? And I'm sure this is happening, but I don't have first-hand information about that, but I'm sure it's happening. Now, these little chips, the illustration on the left is actually quite old. These chips are quite a bit smaller now, are in a lot of things we buy. If we buy high-end products, expensive products, handbags, shoes, expensive clothing, there are people, this is a shock, I know, who are manufacturing knockoffs. And the manufacturers, if you've got a luxury product, the last thing you want are people manufacturing something that looks like yours, but really isn't the same quality. You know, somebody thinks they got a designer handbag or shoes or whatnot, and they fall apart or they start looking ugly very early. So they want to be able to verify that, yes, this is ours. And they also, frankly, want to know if that customer comes back in the store because they know that customer spends money. and they would like to greet that customer and give them custom service so that they buy more. This happens at high-end stores all over the world. I hope this is news, but that's the case. Now, the football helmet. This is from a former student who works for this company. It's their black belt. This is the football helmet that most professionals use. And this is manufactured in Seattle. And the majority now, and that literally the majority of high school football players are wearing this helmet. These are custom made to an individual. It fits their head perfectly. And this includes all the Seahawks, by the way. So every single part on this helmet has got a chip in it. Well, why in the heck would they do that? Besides inventory, they want to be able to manufacture a perfect product that will reduce head injuries. Nothing eliminates them, reduce head injuries. And for that reason, and because they charge a lot of money for these, they want to make sure that nobody's messed with it. So if somebody starts taking them apart, maybe changing something in it, they want to be able to know that that has happened. So far, the chips are not sophisticated enough to register, say, how strong a blow somebody received to their head at any given time, but that technology is coming. So this is part of the spaghetti diagram tool system. We use these things all the time. They track every single part in these helmets. And if you're charging close to $1,000 for them, yes, the customer expects quite a bit. And this way they can deliver that. People will look at this first. This is where our MBA shots most often originated. This is a spaghetti diagram. We don't need to track the actual flight of the basketball, but this changes through the years. If you're a coach, you probably are tracking this type of thing very carefully. And this is very valuable information. This is a graphical display of a lot of information. It makes it very simple, very straightforward. We can understand it. While this might not be a classic spaghetti diagram, indicates it's still an important use of graphical display. This is obviously a World War II era bomber, and when these things would come back, they'd have guys climb all over them and count the bullet holes and note where they are. Well, what do you do with that information? And the best way of representing that, you can describe where the bullet hole is, or you can just use a simple graphic like this. Originally, the plan was, well, let's look at where all the bullet holes are, and then we'll just armor plate those particular areas on the aircraft. And then a mathematician got involved and said, wait, you're looking at this backwards. These planes survived. They came back. They're damaged, obviously, but they managed to come back. We know an airplane can survive this. We can't armor plate the entire aircraft. So why don't we put armor where we don't see any bullet holes, because we know aircraft can't survive those. So not only do you have to gather the information, you have to figure out what the heck it means and what you do with it. And this takes a little bit of thought and analysis. Sometimes the answer isn't as obvious as we'd like it to be. But in this case, it made a huge amount of difference during the Second World War and the survival of the crews. Now this was taken, I took this some time ago. This interchange is not, intersection has not changed a bit since I took it. This is one of the worst in Olympia, standard strip mall, Taco Bell, very popular Taco Bell. And if you can look at my cursor here, we have, not only do we have people coming out of Taco Bell with their food, we have people coming in from the parking lot over here. Over on the other side where this shrub is, there's another little strip mall with auto parts place and something else in there. And so we have traffic coming out of here. This road on the side, this is where deliveries are made to the building. And this is Cooper Point. We have people coming in, we have people coming out. There's no stop sign here. This is what you call a gigantic mess. Who has the right of way when you pull in here? Nobody seems to know. And this has been an ongoing intersection that you avoid if you possibly can. Now, what could we do at this point to repair this, to alleviate this problem? It would be expensive. But this is a problem that needn't have existed at all if somebody had simply used a spaghetti diagram, not only indicating how cars travel through here. Perhaps you'd want to throw in, obviously there's a place for pedestrians. If somebody walks from the workplace to get something to eat, might throw those in there, but you'd also want to track how many cars go in what direction. So you'd park somebody there and they'd be taking notes and finding out how many cars go through there. And you do that for a few days, you'd get a real good idea of the traffic flow. And that person would also be able to tell you what kind of problems you're getting. Are we getting fender benders? Or are people going slow enough that they're simply slamming on the brakes and then cursing each other? Or what's going on here? So again, this is a large amount of information that should be displayed as a spaghetti diagram with a lot of indication of traffic flow. And those things are all measurable. One of the primary sayings in Lean Six Sigma is, if you can't measure it, it doesn't exist. And we can measure darn near everything. And this is one of the basic tools you're learning today. One more. This is again in Olympia. This is the original intersection here. Now this one, for years, this McDonald's has been there, and for years, notice they have cars coming in here, you have cars coming out, you have cars coming around a blind corner right in front of the drive-through. You have people who got out of line for whatever reason, they're coming around. And then you got, originally, they had a lot of people coming in from the sidewalk out here. And this was Harrison, pretty busy road. A lot of fender benders, a lot of people confused as to who has the right of way because nobody knows. It's a great big mess. How could that have been avoided? Well, if you were asked to come in and analyze this, you'd need yourself a whiteboard and a marker. Boy, talk about exotic. That would have gone a long way to prevent that. And eventually they did it. Just this year, they rebuilt this store, and this is the same intersection you're looking at now. Notice how they're controlling traffic so tight. So they've eliminated a lot of the confusion, and they've rerouted a lot of the traffic away from this one major entry into the store. Could that be done originally? Of course. Of course. There's no reason for all those years of people smacking into each other or almost clipping a pedestrian or stopping in the middle of the road, blocking it for other people. None of that needed to happen because it could have very easily been analyzed ahead of time. We can figure out, we know how many cars travel on given city roads. Talk to your city traffic engineer, they can tell you. And this is a very preventable problem. Typically, if people want a real pretty spaghetti diagram for maybe they're doing a formal presentation to management, Visio, if you can buy Visio, is great. It's expensive. Licensing is expensive, but it is gorgeous. It's true. Or you can go old school and use graph paper, which I still frequently use. Graph paper, every square is 1 square inch or 1 square foot, I should say. And if you're taking this class from me in person, I send students out with tape measures and graph paper and do the entrances to the building. They track how many people come and go and which direction they went. They track all of that, and they can do that within a half an hour and come back with a very good analysis on the traffic flow within that building. This isn't rocket science stuff. It's pretty straight ahead measurement. works pretty well. Now you can also use Excel, and there's this is a link to a YouTube video of how to use Excel to do the very same thing. This is probably a software you already have. You can draw your own squares and circles, or you can even download some of the symbols for these things. So it's not something you have to have the right software for. You can just simply use a whiteboard if you need to. Works perfectly well. Isn't as pretty, but it works perfectly well.